In this next section, 9, we're going to continue looking at the volume of a solution, but we're going to use the cylindrical shells method. You need section video so that you can use the foundation of how to approach these problems to apply to this homework problem. It's homework problem number 3 that we're looking at. Precisely, we're going to look at number 4, which is very similar to the number 3. But follow that section video first and take some good notes so that you understand each of these steps as we move quickly through them. We're going to start by sketching the region bounded by x cubed, y equals x cubed, y equals 0, x equals 1, and x equals 2. That's the shaded region. Take the shaded region and rotate it around the y-axis. So from the outside we get a cylinder, but you could see that through the top or bottom you'd see that it's actually hollow in the middle. But each of the little cylinders is going to have a different height based on where we're hitting this blue. The volume of one of these shells is going to be the circumference. So that's going to be 2 times pi times radius, or in each of these cases you'll see that the radius is x, or if we're integrating over y, it's a dy, then it would be 2y pi. But if we're integrating over x, it's 2x pi times the function. In this case, it's this blue x cubed over dx. I'm going to move this page up as we continue from here. This 2 pi x times x cubed could be simplified by removing the constants 2 and pi and multiplying the x and x cubed to get x to the 4th. So we get 2 pi equals 2 of x to the 4th dx. So that's 1/5 x to the 5th integrated from 1 to 2. When we let 2 substitute in for x, you get 32 over 5. When x equals 1, we get 1 over 5. So it simplifies to 31 over 5. And then multiply pi gives us 62 pi over 5. Be mindful of where you put the pi in the final answer, because the pi is in the way we write it. So the 62 over 5 is a coefficient. But be sure that you're not writing it in such a way that puts the pi in the denominator. You could either write the pi in the numerator or write the pi where the coefficient is 62 over 5. The pi is clearly taller than the 5. But if we write it too quickly, 62 fifths times pi, if the 5 and pi are the same height, it could look like the pi is in the denominator. So just be careful how you're writing that. You will note a pattern for every problem. And again, I encourage you to review the section video so that you can get a better foundation of where this formula comes from. But in every case, the volume using the cylindrical is simply 2 pi times the integration from a to b, the two endpoints, of x times f of x, or if we have an f of y, it's y f of y integrated over dx, or if this was f of y, it would be integrated over dy. Let's look at an example. And this is example number 4 in the textbook. Oh, I'm sorry, that's the same one we just did. This is example number 5 in the textbook, which is the problem that is assigned. And since this one is assigned, it's precisely how it's assigned. And who is a Stitch, I think is his name. We've brought in our Stitch from Lilo and Stitch to help us with this video. Don't forget to make note that Stitch is the character, the guest who stepped to help us with this problem, so that you could get some additional extra credit points that comes up. For number 5, here in section 5.3, we've got the functions y equals 4 and y equals x squared, and we're going to integrate this from x equals 0 to x equals 2. So the height of these cylinders. When we rotate this around, we get a shape kind of like this. And each of those cylinders inside, pull it apart, it would be a rectangular prism. But notice that the height, this blue height, which because I put it over the highlight, it turned green, is going to be the difference between y equals 4 and y equals x squared. So we have 4 minus the x squared to get the height of this rounded bowl shape. So when you attempt number 5, you're going to use 2 pi from x equals 0 to x equals 2, x times 4 minus x squared integrated over dx. I hope that Stitch and this help you get started with that problem. Let's look at the next example. This example is number 9. Have with number 9 is we have, or I'm not going to work number 9, I'm going to work number 10, which is similar. So we're rotating over the x-axis because we have y equals the square root of x equals 2, and rotating over the x-axis. So the cylinders would look something like this, where the volume is the circumference of the circle times the height of the cylinder is going to be f of y, and then the integration goes dy. So when we set this up, we'd have the volume equals 2 pi from 0 to 2, y times f of y. Now, we're given y equals the square root of x. So if we need f of y, we need to solve for x. And we could do that by squaring both sides. If you need to, you could pause closely at this algebra worked out. But when we do this simplification, we end up with the volume equals 2 pi times the integral 0 to 2 of y cubed dy. That y cubed comes from y times f of y. So we get 2 pi times y to the 4th over 4 from y equals 0 to y equals, in other words, 8 pi. That's number 9. And from section 5.3. Number 11 asks us to take the area bounded by y equals x cubed, y equals 8, and x equals 0, that's this shaded region, and rotate it around the x-axis. That gives us a cylinder that looks like this. And what we're going to do is then use the cylindrical, pull out some cylinders from inside function, and find the volume of the solid by integrating the times the height times the width of, we opened up this cylinder and rolled it out. So what we have here is, just to get you started with it, is we're going to integrate from y equals 0 up to, from y equals 0 up to y equals 8. And we're integrating y times f of y, that's the blue, to the cube root of y over dy. So I hope that this hint helps you get your problem number 11 started. But if you'll follow the examples in the previous examples of the other problems worked out in the section, you'd follow this one through with the same method. But I hope that the sketches help you get a start on that.